All right, ladies and gentlemen, Chapter 3.3, Graphing Systems of Linear Inequalities. If you prefer, you can find these steps on page 168 in the textbook if you want to look at those. So I'm just going to read through the steps and then we're going to do a couple of examples. If you want graph paper, you can find graph paper at the back of the room in a basket. Otherwise, you just need to do it freehand in your notes. All right, so step one, we're going to graph each inequality in the system, and then we need to identify the region that is common to all graphs of the inequality. This region is the graph of the system. Okay, I'm going to do it a little bit different with the shading, okay, and I'll talk about it as we go. All right, example one. Graph the system of two inequalities. All right, so we're going to graph it like a regular equation. So we're going to mark the y-intercept. So the first one I will do is this one. So the y-intercept is 1. Remember, that means up 1. Okay, and the slope is 2, so up 2 over 2. Okay, I'm going to finish graphing that. Before I draw the line, I need to identify what type of line it is. Okay, so it's a less than. It does not have an equal to on it, so that means the line is going to be dashed. All right, now if I shade this, okay, I do not need to check a point because it's in slope-intercept form. So to shade it, it says less than, so that means I am going to shade below. So let me pick yellow. All right, so I'm going to shade below that green line. So this is the solution to that inequality. All right, now I'm going to graph the other one on the same coordinate plane. Do that one in purple. All right, the y-intercept is -3, so I'm going to start at -3. And the slope is telling me, okay, slope is telling me -1 over 1, so down 1 over 1. Now I need to identify the type of line. So it's less than or equal to. So therefore, it's a solid line. All right, it's also a less than, so that means I need to shade below the line. Okay, so I need to shade below the purple. Let me pick a light green. All right, so I'm going to shade below the line. I'm shading completely below the purple line. Now, you will notice that there is a region that overlaps, okay, right here. I'm going to shade that a little bit darker. That is where the two overlap each other. And that overlapping part, ladies and gentlemen, just a second. That overlapping part is the solution to the system of linear inequalities. This part right here is the solution region to the system of inequalities. Okay. Again, at any time, you may pause and rewind. Okay, continuing. All right. So I'll do this first one in green. It's already in slope-intercept form. So start at 1. And the slope is down 3 over 4. Okay, it also tells me it has an equal to underneath, so that means the line is going to be a solid line. And I can shade that one. I am going to shade, it's less than means shade below. So I'm going to shade below the green line. Okay, now the other one. Now, this one, y is not by itself. So I'm going to go ahead and for this problem, I'm going to solve for y. But in the next example, I'm going to demonstrate sometimes you don't need to do that. But in this one, I am going to go ahead and solve for y. So let me rewrite it and get y by itself. So first thing I'm going to do is take away the 3x. Okay, divide everything by 4. All right, so now I'm going to graph that. Just a little reminder, if you divide by a negative, okay, don't forget you have to flip the inequality. So look out for that. Again, if you end up dividing by a negative, you got to flip the inequality. All right, let me graph this one. So the y-intercept is 4. And the slope again is down 3 over 4. And since they have the same slope, these two lines should be parallel to each other. And it does not have an equal to on it. It does not, so it is a dashed line. Now, I didn't talk about this with the first example. A solid line means it is part of the solution. A dashed line means it is not part of the solution. Okay, so back to the purple. So that says greater than, so I'm going to shade above that line. So there is no overlapping region for these two graphs. So that means they don't share anything. So there is no solution to this linear system of inequalities. Okay, there's no overlap. All right, let's look at another one. Okay, so for this one, I am going to, instead of solving for y, okay, I'm going to use, remember, the cover-up method. So I'm going to make believe the negative x isn't there. So I have 3y is greater than negative 6. All right, now I don't need to worry about the inequality, so I'm just going to put an equal there. So 3y equals negative 6. Divide by 3, and we find that the y-intercept is negative 2. So y-intercept is negative 2. All right, negative x. Cover up the 3y, so negative x equals negative 6. Divide by negative 1, so x equals positive 6. All right, that's all we need, minimum 2 dots. Now, we look at the inequality. Okay, it does not have an equal to on it. No equal to, so it is dashed. Now, here we have to check a point. For this problem, we must check a point. And remember, pick 0, 0 if the line is not going through it. So you plug 0 in, you plug 0 in. 0 times anything is 0. You add zeros together, you get 0. So it says 0 is greater than -6. That is true. So that means we're going to shade the side that has 0, 0. Okay, so we shade above this one because that's the side that has 0, 0. All right, I got to shade or graph the other line. Now that one again is already in slope-intercept form, so I'm going to start at 1. I'm going to go up 1 over 3, up 1 over 3, and so on. Well, how about that? This one looks like it's parallel. It's got an equal to on it, so it is going to be a solid line. And if I shade this one, now this one I do not have to check a point, I just need to shade. It says shade below the green line. So when I shade below the green line, I notice there is an overlapping part. The overlapping part for this one is right down the center. Okay, right here. So that is the region that is the solution to this system of inequalities. All right, so that's it for chapter 3.3. We're going